All right, welcome back. This is part 4 of the video series. I know it's been several months since part 3. I highly recommend looking at all 3 parts. Even if they are a bit long, there's a lot of subtext. And it'll definitely bring a lot of context to what we're going to be discussing today, which a lot of it is going to revolve around microRNAs, G quadruplexes revisited. Some news coming out regarding cardiomyopathy. We'll get to that. Yeah. A few other things, observations with regard to both the virus and the so-called therapeutic. Of course, by that, I don't mean the monoclonal antibodies. I mean the science experiment. So I guess we're gonna open up with yeah. I haven't actually read through it yet. Should have, but yeah, we've got a paper here, and I believe it's in preprint, and it's differences in vaccine and SARS-CoV-2 replication-derived mRNA, implications for cell biology and future diseases. So essentially what it means, they kind of did a big doo-doo when making the synthetic mRNA injection thing. And in doing so, yeah, there's consequences to that. And you could say there was a doo-doo on accident, or it was a doo-doo on purpose. It doesn't matter. Not really. It does in a certain sense, but it doesn't matter to your health. Though it can, because it can indicate, one way or the other. What, who done it? Why done it? We're led to believe this is all an accident. Fair. All right. We'll leave it at that. But let's get back into it. So here we have 3 different spike protein sequences: Moderna, Pfizer, and SARS-CoV-2, analyzed with RNA-Fold, which is a software, highly developed software. Not only are the secondary structures of the mRNA noticeably different, of note is the increased number of G quadruplex formations in the codon-optimized mRNA vaccine, figure 3, which is this is figure 3. G4 formations in the RNA sequences for nucleoplasmid protein have been proposed as an attractive drug target, or has attractive drug targets, to eliminate nucleoplasmid expression. This is achieved by using compounds that stabilize quadruplex G formations, G being guanine. G4s are also implicated in the recruiting of viral SAR's unique domain, NSP3. While the mRNA vaccines do not encode this non-structural protein, an increased number of breakthrough infections must consider the biology of both the virus and the non-native vaccine-derived mRNA. With increased vaccination rates and continued boosters, it will be increasingly important to understand the immune status of patients expressing both mRNA-based vaccine spike proteins concurrent with viral spike protein expression. The changes to secondary structure can be observed in the G4 formations, seen in each sequence using G4s mapper, figure 3. That's the software that was used to produce that. Similar trends were observed using M4IM grinder, personal communication Belmont. That's another tool. Let's see, 3 sequences analyzed with the above mentioned tool, only 4 G4 motifs are identified in the spike protein, spike coding region of the virus mRNA, on the left. 19 G4s are identified in Moderna, middle, and 9 G4 motifs are identified in Pfizer, right. Does the increase of 4 to 19 G4 motifs and the translation efficiency of these proteins, do they create truncated spike proteins not seen with natural virus? It's a good question. It's a good question. Anyway, this is definitely, this is not a read along. It's not why I'm making this. That being said, this is an excellent paper, I believe. I believe that this is right where I'd like to see the research going in terms of direction. Yeah, you know what? It's even for the layman. Okay, yeah, and this is all sources. Okay, so we've got 9 pages. Really not killer. Could do that. And we can get into other bits. So G4s and their involvement with CMYC. It turns out piperine is a great stabilizer of CMYC G4s. Keep that in mind in the future. You never know. It seems to be in any case, which is what I've been hypothesizing. What else do we have here? Right. EIF4A dependent oncogene translation. I remember this was particularly interesting. Let's try to pull this up with something that was Silvestrol. Yeah. So it turns out that Silvestrol. Yes. There we go. It acts as a potent and selective inhibitor of the mRNA of the RNA helicase enzyme EIF4A, and has broad spectrum antiviral activity against both such diseases as Ebola and coronaviruses. Interesting. Of course, there are many types of coronaviruses, and this is just one of them. Of course, it also has anti-cancer properties, which makes it of considerable interest in medical research. Okay. Now, how this compound interacts with the biome, what is causing it to, have antiviral activity against Ebola and coronaviruses, I don't know. But as far as a correlation between coronavirus and anti-cancer properties, we're starting to get close here with the previously mentioned research. Also, a few other things, for sure. Fundamentally, what's interesting about quadruplexes is that they can produce methylguanine. So you basically have a methyl group attaching to guanine. And now, this is a rare occurrence, or it's supposed to be a rare occurrence. What will happen is that this will happen within, normal double-strand DNA. And then you have methyltransferase enzymes, which will, help repair that. What will end up happening in this case, or in some cases, we're going to get to the whole accusation part, is that this methylguanine may actually form G4s. It's highly unstable, which is a bad thing, very dangerous thing. Not much can be done about it other than preventing it from happening. When you end up with methyl groups in your guanine, that's basically a symptom of inflammation. You end up with runaway, oncogenic activity, Now, in the case of, say, some sort of freak show methylguanine quadruplex, which does naturally occur, but let's just say they've been instigated or supported through a deregulation of potassium ions or something of that nature, then you could be looking at something extremely dangerous. And not necessarily for something in the case of cancers, because it's strangely rate limiting. This might be left for part 5, I think, or not at all. But it's definitely worth a mention at the very least. Of course, it's a promising cancer therapy target. Yeah. Now, microRNAs involved and associated with COVID. Yeah, that's cute. COVID-19 and methyl acetylate group. Why didn't I bring this up earlier? Yeah, it's quite interesting. But microRNAs. Now, the deal with microRNAs is that you're dealing with multiple microRNAs that, there's very little research in this domain, or there is a lot of research. There isn't all that much information. It's still going. It's still ongoing. That being said, it's a lot like, the initial research was like, oh, well, we found, say, MIR31. We found lots of it in a cancer patient. And therefore, we assume that MIR31 is symptomatic of cancer. But it turns out that that's like completely false. It took literally 2 days for them to figure it out that, oh, like these things are weird. You've got a lot at certain times of the day. They're basically like these signaling molecules, but they interact with your RNA. They interact with transcription enzymes, RNA polymerase 2. That's my typing. Yeah. Okay. Drosha. Yeah. So like what microRNAs, which is something that it's miRNA and not mRNA, confusing for people who read too fast. These things can actually leave the cell, and then they go into other cells, and they actually signal this way. Signal, do changes, all kinds of systemic interactions, and yeah, they're just as susceptible to, pardon my French, but fuckery. Right. I'll be leaving these. These are all pretty interesting reads. Now, how did I come across this paper? Right. This I might bring back for part 5. We'll never know. Or I'll just leave it in there, and if anybody finds anything interesting, you let me know. Right, we've got that one out of the box. Yeah, that one too. Yeah. Okay. Now, what was particularly disturbing is, here we go. Was it today? Was it last week? Here we go. G4 resolvase RHAU regulates ventricular trabeculation and compaction through transcriptional and post-transcriptional mechanisms. Yeah. This is a heavy one. So it seems that G4s can you know, cause the heart problems that everybody's been having. And not a whole lot can be done about it other than maybe eating pepper and taking some. Yeah, I don't recommend taking silvestrol, but hey, it could help. Now, in the case of anybody who's suffering from cardiomyopathy, I don't think that can be helped all that much. It can be managed. Swing for the fences, I suppose. But yeah, there's a word for it, and it starts with an F and it ends with an ut. This is a very important piece of information here, especially for anybody who's suffering from side effects of either the virus or the supposed virus preventative. Yeah. So we'll give that a go. I would recommend pepper. Okay, so we also have this other piece of paper. Well, it's obviously not a piece of paper, but another paper from the BMJ. COVID-19 researcher blows a whistle on data integrity issues in Pfizer's vaccine trial. Yeah, they lied. And who can finish that sentence? Look, people do it all the time. Researchers do it all the time. So I'm not surprised in the least bit, especially considering the scale and scope of everything. But apparently, if you post this on Facebook, they'll just remove it and say that it needs to be fact checked. And I mean, this was the front page of the BMJ, so yeah, I guess they don't want boomers and normies sharing this. Cool. So, got some more papers here about mRNA. Deregulation of microRNA expression is associated with endothelial dysfunction in post-mortem lung biopsies of COVID-19 patients. Based on functional analysis. So these guys here, right? Anyway, I'll leave this for reading. I'm not going to go into it. It's a tongue twister. They're all tongue twisters. It's definitely not not something that's very easy to discuss. I'll just, circle my mouse over that. And there's more to it. There's definitely more to it. Oh, what's this? Recent progress on relevant microRNAs in autism spectrum disorder. Interesting. Well, which ones do we have? What's going on here? Oh, other things. Sorry. Let's have a read here. What's going on here? Okay. I mean, I could pretend I know. I'll tell you I don't, but I can read along. Okay, so results. All right. This seems to be, this is definitely an interesting one. One of the many. What we got going on? Let's just do a, just follow with me here. Let's. Oh, interesting. A lot of information about this. Okay. What do we got? No, not invermectin. that right there tells me of the many things it could be, this is definitely one of them, or it's one of the very probable reasons for it to be beneficial. Now, if you drop a feather and a brick at the same time and they land on your head, does it matter which one came first? That's not that's not the question you'll be asking. This is another interesting one. Now, this is very particular. It involves, MIR 4456, if I'm not mistaken. I do actually have to look it up. I'm not. Right, yeah. Hypersexual disorder. Putative influence on oxytocin. What does that have to do with CCL3 and CCR5? That's interesting. And how does this have anything to do with COPD? Interesting. This is definitely worth a read. In fact, most of the oxytocin stuff is worth a read. A lot of the microRNAs that are involved with the disease and its supposed friend, the preventative, a lot of them will throw out of whack certain neurotransmitters and hormones. Well, we've touched down on certain hormones before, but in this case, it's much more insidious. It's much more slippery and hard to. Yeah. So I'll leave that one there too. It's definitely a good read. I'll have them sorted. Actually, I think the last bunch have just been a heap, which in my fucked up brain is ordered in some way. But yeah, I'll try to be, more noob friendly. All right, so that's about it for now, I think. Yeah, and yeah, if anything develops, I'm gonna try to knit that yarn and get it going well. See if I can't pull up any kind of at this point, it doesn't really much matter because I'm just abstaining for myself. I'm abstaining from the that shit. I recommend others do, but of course, I have to put that disclaimer that I'm not your doctor, or else somebody might sue me or something. But so I'm good. I'm gold. I'm gold 1-4. No, no, but really, I'll be all right. I think. I caught COVID. I beat COVID. Some people don't, and long COVID is a reality. I think that doesn't get enough interest actually, given what it does and how it affects the patient. Much in the same way that what's that one there? Lyme disease is a real thing, and for a very long time, people thought that it was just bullshit. People were just being, what do you mean you're always tired? You're just lazy, like things like that. Long COVID is a reality, and it doesn't necessarily manifest in the most physical of symptoms, but yeah, neurologically speaking, there is some demon sorcery happening there. So yeah, keep your eyes posted for that. So I'll leave you now on this fine night. It's a fine evening. 8:50 p.m. Oh, it's almost 9 o'clock. All right. So that's that. I recommend giving everything a read, making your own decisions and making your own conclusions. I'm not there for that. I'm really just a newsman, a shitty one at that. I have my own opinions, I have my own observations, but sharing them as much as I'd like to, I feel like at this point, unless asked, is irrelevant, right? Since it's a moot point. It's for me, it's my interest, my health. Am I sharing it? Of course. So if anybody has any questions regarding any aspect of this, feel free to ask away. I'll be there in the comments looking. Um, but yeah, it's there's a lot going on.